Hello guys, my name is Pritpal Singh. I qualified UGC and JRF in 2022. Today I will explain the descheduling in the operating system. So let's start the session. So what is descheduling? As we know that a process needs two type of time, CPU time and the IO time. IO time means input output time. For IO, it requires the operating system to access the disk. However, the operating system must be fair enough to satisfy each request, and at the same time, operating system must maintain the efficiency and the speed of the process execution. The technique that operating system uses to determine the request which is to be satisfied next is known as the descheduling. In simple words, the order in which the operating system will process our disk request is known as the descheduling. So why we need the descheduling algorithms? As we know that in our multi-user environment, there are multiple users and there are the multiple disk requests from the users. So what operating system will do? Operating system will maintain a queue of that request and services that disk request one by one. So operating system will follow a order so that so that it can reduce the waiting time of the disk access. So as I explained that in our system, multiple requests are coming to disk simultaneously, which will make a queue of requests. This queue of requests will result in increased waiting time of request. The request wait until the under processing request execute. To overcome this queuing and managing the time of this request, this scheduling is important in operating system. Also, it may be possible that the two different requests are far from each other. Like one request is at spot from where the disk arm is near, and the other request in on different spot of drive from where the disk arm is farther. Here, disk scheduling algorithms helps and reduce the disk arm movement. The requests that are close to the disk arm will be serviced quickly, and for the farther request, the disk arm needs to be moved from its location. Disk arm is the part of the hard disk which moves to a different part of hard disk, approaches requests, and serves them. Using disk scheduling, data can be accessed easily without wasting much time. So, main agenda of this scheduling algorithm is that we have to minimize the movement of the disk arm so that we can reduce the waiting time of the request. Next one is the disk architecture. Before discussing the disk scheduling algorithms in detail, we have to first learn what is the architecture of the disk. So hard disks are the secondary devices we can use to store data. Most modern computers use hard disks to store large amount of data. So in the architecture of the disk, there are mainly these five components. What is that? First one is platters, spindle, read-write heads, and tracks and sectors. Okay. Firstly, we will discuss the platter. What is platter? This the concentric disk is known as a platter. Okay, so hard disks are organized as a concentric stacks of disks. An individual disk is referred to as a platter. Each platter consists of two surfaces, a lower and the upper surface. For example, this is the platter. So there are the two surfaces of this platter. First is the lower upper one, and the second one is the lower one. Okay, so here, this is the platter. For example, in this diagram, we have three platters: first one, second one, and the third one. So there will be the six surfaces because each platter has two surfaces. For example, in this case, we have three platters, so there will be the six surfaces. Okay. Next one is the spindle. So what is spindle? So it is a non it is known as a spindle. The platters within the hard disk are connected by a spindle that runs through the middle of the platter. The spindle moves in the unidirectional manner along the axis, either clockwise or counterclockwise, that is anti-clockwise. The movement of a spindle causes the platters to the rotate as well. So this disc have to be rotate. So what will the spindle is responsible for the movement of the disc. So the spindle will move, and that is why the over disc also move. Third one is the read write head. So what is read write head? For example, this is the read write head. This is the ARM assembly which consists of the read write head. Each platter has two read write head. It's very important to note that each platter has two read write head, for one for the upper surface and one for the lower surface. For example, this black dot is known as the read write head, and it is the known as the ARM. So this is the known as the ARM assembly. ARM assembly is consists of read write heads for each platter. Okay, so it is known as read write head. Next one is the tracks. What is track? This is the concentric circles is known as the tracks. Okay, this is the green shaded portion is known as the track, and the small portion of that track is known as the sector, where we have to store our data. What is track? Each surface of platter consists of a fixed number of tracks. These are circular areas on the surface of a platter that decrease in the circumference as we move toward the center of the platter. Data is first written to the outermost circle. Okay, so that is the this concentric circles on the surface of the platter is known as the track, and then the small portion of that one track is known as the sector. Okay, each track is divided into the fixed number of sectors. Sector divides track sections and store the data in which we have to store our data. The smallest unit, we can say that the smallest unit is the sector. So let's discuss some important terms related to this scheduling. First one is the seek time. Second one is the rotational latency. Third one is transfer or the transmission time. As we discussed, this is the platter. So this is known as the track, and the small portion inside the track is known as the sector. So there are multiple times to test these portions. So what is seek time? Seek time is the time taken in locating the disk arm to a specific track where the read-write head requires to be satisfied. What is seek time? We discussed the read-write head. So time taken by a read-write head to go to the desired track is known as the seek time. For example, we have to this is the read-write head. Okay, so we have to go assess this track. So we have to go from this portion to this track. So this time is known as the seek time. As discussed in this diagram, we have seen we can see that this is the seek time. So what is the rotational latency? It is the time taken by the desired sector to rotate itself to the position from where it can be accessed the head. It is the time. What is rotational latency? The time taken by the disk to rotate the disk so that the desired sector is under the read write head is known as the rotational latency. For example, we want to assess this track. So the disk will be moved, then this sector will come under the read write head. So that time it is known as the rotational latency. Okay. Then last one is the transmission time. Transmission time, we have to read or write the desired sector. The time taken to read or write from the desired sector is known as the transmission or the transfer time. So we can that the full disk access time given by the rotational tendency plus seek time plus the transfer time. Firstly will be the seek time. So in which what will be done? The read write go to the desired track. Then rotational tendency so that we can move the desired track under the read write head. That is known as the rotational tendency. Then we have to write or read from the desired sector is known as the transfer time. So disk access time will be the summation of these three terms or these three times. Okay. So let's move to the next slide. So next slide is disk scheduling algorithm. The list of various disk scheduling algorithm is given below. Each algorithm is carrying some advantages and disadvantages we will discuss in respective disk scheduling algorithm. The limitation of each algorithm leads to the evolution of new algorithm. The limitation of one algorithm will lead to the evolution or the discovery of new algorithm. So basically there are six algorithms, disk scheduling algorithm. First one is the FCFS, that is first come first serve scheduling algorithm. Second one is SSTF, shortest seek time first algorithm. Third one is scanner scheduling algorithm. Fourth one is C-scan scheduling algorithm. C matlab circular. Look scheduling algorithm, and C look. C means circular look scheduling algorithm. So we will discuss one by one this algorithm one by one. So first one is the FCFS. FCFS means first come first serve scheduling algorithm. It stands for first come first serve. As the name suggests, the request which comes first will be processed first, and so on. Simple agenda is that the requests coming to the disk are arranged in a proper sequence as they arrive. Since every request is processed in this algorithm, so there is no chance of the starvation. We will discuss what is the starvation in later slide. So FCFS means the request which will arrive first will be serviced first. Okay. For example, in any admission in any college, there will be advertisement. There are some seats vacant in some department. The seats will be fulfilled on the basis of the first come and first serve. okay, or any job will be fulfilled or a seat will be fulfilled on the basis of first come and first serve. The person who will come first will be served first. So that is the main agenda of FCFS. Okay, so there will be no starvation. Starvation means there is no any biasness. The person who will arrive first will be purpose first. It will not happen the person will come later and will be served first, or a person which will come arrive or which arrive first have to wait for a long time. So fairness is the main factor of the FCFS. So this algorithm is fair. There is no any biasness and there is no any starvation. Starvation means the process does not need to be wait for the indefinite time. Okay, so let's discuss the example, numerical example, so that we can more easily understand this algorithm. Example is that suppose a disk having 200 tracks. We have already discussed the track. What is track? This is the concentric circles on the surface. Okay, so it means that we have 200 tracks per surface. We have the 200 tracks. We can number from 0 to 199 as we start from a 0. So there will be the upper limit is 199. The requests sequence are 82, 170, 43, 140, 24, 16, 190 of the disk are shown in the figure, and the head start is the request 50. Photo example is that these are the request of the disk. Okay, we have to be service. So what this algorithm will do that the which request is arrived first will be service first. So it means that currently we are the 50. For example, these are the tracks in this diagram. We have 0 to 199 tracks. Okay, currently we are at 50 number track. Okay, so the request which will be arrived first will be service first. For example, first is 82. We start from the 50. 50 we will go to the 82. Okay, 82. Then we go to the 170. Then we will go to the 43. Then we will go to the 140. Then we will go to the 24. Then 16, and from 16 to then 190. Okay, so this is the FCFS algorithm. I am explaining it in slide also. In this above image, we can see that the head start at position 50 and moves to request 82. After serving them, the disk arm, sorry, this arm moves toward the second request, that is 170, and then to request 43, and so on. In this algorithm, the disk arm will serve the request in the arriving order. In this way, all the requests are served in the arriving order until the process executes. Seek time will be calculated by adding the head movement. So we can of course calculate the seek time. How we can calculate the seek time? We have to be plus this the this movement. For example, we will go from the 50 to 17 for 50 to 82. So we will this is the one movement, then 82 to 170. This is this movement. So we have to be uh, add this time. Okay, like 82 minus 50 plus 170 minus 82 plus 170 minus 43 plus 140 minus 43. So we will add all these times, and then the summation will be the seek time. Seek time means how many movement will be done to serve all these requests. So to serve all these requests, these 7 requests will be served in 642 movement. It means in FCFS this have to be move for the 642 times to service all these 7 requests. This is very huge amount of movement. That is why FCFS is not generally used, because it will lead to a lot of unnecessary movements. Okay. Firstly, we will before coming to the advantages and the disadvantages of the FCFS, let us explain the dish scheduling algorithm. Not only FCFS, all the dish scheduling algorithm to the analogy. What is the analogy? For example, as a teacher, I assign a task of reading some chapters of books. I am giving a task to the student to read the some chapters of a book. The strategy that will be used by the student to read the chapters is very much related to this scheduling algorithm. So let us, as we discuss the FCFS, so we can relate this example with the FCFS. Then we will explain that this example with all remaining algorithms. So what will be done by a student. For example, I will give a book to read some chapters to student. So what will student do? Student will follow some strategy to read the chapters. For example, I am giving some chapters. For example, there are 200 chapters in the books, and I am giving only 7 to 8 chapters to students to read. Okay, so I am write the chapters numbers in the blackboard or whiteboard. Chapter number 2, chapter number 14, chapter number 35, chapter number 27. I am written in the blackboard so that it can be noted by the student. So student will be what will be done by student. The student will follow the exact sequence as I am write on the whiteboard. For example, first I will write chapter number 2. He will read chapter number 2. Then I will write chapter number 50. Then he will read chapter number 50. Then I write chapter number 34. Then student will write chapter number read chapter number 34. So student will follow only that sequence which is written by me or which I will order to student to read. Okay, so in what will be happen in this algorithm or in this strategy followed by student, there will be unnecessary movement of the book. For example, after reading chapter number 3, he have to read chapter number 40. So student has to towards the remaining chapter between chapter number 3rd and chapter number 4, like chapter number 4, chapter number 5. They don't have to read, but he has to traverse the chapters until he will reach to the chapter number 40. So there is a unnecessary traversing of the book chapters in which they have to not have to read, because he have to read now chapter number 14. But before moving to chapter number 14, he has to traverse chapter number 4 until chapter number 39. Okay, he have to traverse the chapter so that he can reach to the desired chapter, that is the chapter number 14. So it is the unnecessary movement or the unnecessary traversing of the book chapter. Similarly, this example hold for the descheduling algorithm. For example, we assess after assessing the sector number track number 82, we have to assess that track number 170. But between 82 and 170, these have to assess the remaining track between 82 and 70, and there is the unnecessary movements from the 182 to 170. Okay, then there will take a lot of time, because as we know that this hard disk is the mechanical one, and the movement take will take a lot of time. The transfer time is very less than the of course the movement time. The movement time will take a lot of time, which can be less than the transfer time. For example, transfer time will take 2 minutes between the and for the seek time or we have in the movement it will take 10 times. So it is very necessary to so that we can remove or we can lower the movements. We can lower the movements. Okay. Hope I will explain this analogy with the algorithm. So we have to choose that algorithm or that strategy so that we can reduce the movement. Or in this example, so we have to read that particular 7 chapters. We have to student have to make a strategy. So what will be the order to read the chapter, because he has to read all the 7 chapters. But what will be the order to read the chapters so that he can uh, less movement, less traversing to reach that desired chapter. Okay. So, what is the main advantages of FCFS and disadvantages of FCFS? FCFS mean there are some advantages of first come first serve. Every request gets a fair chance, as we discussed in starting of FCFS. Every request gets a fair chance. There is no any starvation. The request which will arrive first will be serviced first, and there is no any starvation. No indefinite postponement, of course. Same example. So, what is the disadvantages? It does not try to optimize seek time. Of course, main disadvantage of FCFI, there is a lot of movement of the disk arm. So it will not optimize seek time. There will be a lot seek time matlab, means there is a lot of movements. So it will very high level of disk movement in the FCFS. May not provide the best possible service. Of course, the best possible service is not best, because it will generate lot of movements, unnecessary movements. So now next one is the SSTF. In SSTFS, SSTF means shortest seek time first. In SSTF, requests having the shortest seek time are executed first. So the seek time of every request is calculated in advance in the queue, and then they are scheduled according to their calculated seek time. As a result, the request near the disk arm will get executed first. SSTF is certainly and the improvement over FCFS as it decreases the average response time and increases the throughput of the system. As the name suggests, shortest seek time first. It means that the track which will be the near the current position or the current track will be serviced first. For example, near 50 we have 43, so we will fulfill the 43 number request first before going to some other request. Okay, so in this algorithm, firstly we have, for example, we have the 7 request. We will arrange this request in the uh, ascending order. Okay, and then request and then services they request accordingly. For example, as the same example, we are at current position at we are at 15 number track. Okay, so there are two ways. Before from 50, the movement can be done to the 43 or it can be the 82, and we have to calculate which will be near to the 50. Okay, between 50 and 43 there is the difference of 7, and between 50 to 82 there will be the difference of 32. So which will be the less? Of course 7 is less. So this arm will move to the track number 43. Okay, then 43, from 43 there is a two option. It can be go from 43 to 24, or it can be go to the 43 to 82. Of course for 24 is less, so this arm will go to the track number 24. Then track number 16. Okay, then from track number 60 it will go to the 82 because no other request from lower side before less than 16, so it will go for the another, which of course 82. Then 82, then it will go the 140. Okay, because of course 140 is near than 170. Of course we will serve 140 first, and then it will go to 170, and then it will go to the 190. So main agenda in this algorithm is that we have to first calculate the seek time. Okay, nearby seek time. We have to subtract that nearby position. So the only that track will be chosen which have a less seek time or less movement. That will be the assessed first in the shortest seek time. Coming to the analogy, that same example, the student will lead the, for example, I am at the chapter number 5, and I have to read the chapter number 7 and chapter number 1. Okay, so what will be the next chapter I will read? I will read chapter number 7 because between chapter number 5 and 7 there is only one chapter, that is 6. Only two have I have to traverse only two chapters. Between between chapter number 5 and chapter number 1 there are four chapters I have to traverse. So there have less traversing in the which algorithm in which movement, chapter number 7. So I will do chapter number 7. So that is the same example I have choose for the this example. Okay. So we can again calculate the seek time, that is the movement. Let's say uh, 53 minus 43, 43 minus 24, 24 minus 16, 16 minus 82, 82 minus 140, 140 minus 170, 170 minus 190. We have to take more. If we get the negative value, we have to be choose positive values only. Okay. So total seek time in this case, in this algorithm is 200, which is very less than the FCFS. That, that is 600 something. It is 2008, 208, sorry. So it is very less than the FCFS. So main advantages of SST is that the average response time decreases. Of course, the request will serve very quickly. The response time is of course decrease. Okay, throughput increases. Throughput means the number of requests served per unit of time. Per unit of time, the request will which will be served is increased in case of SSTF. So throughput also increase in case of SSTF. What is the disadvantages of SSTF? First is overhead to calculate the seat time advance. We have to calculate. Firstly, we have to calculate which track is near from the current position. We have to calculate. Calculation is done by subtraction. It has the less movement. It has the highest more movement. So we have to choose the less movement part. So we have to calculate first. So it is the overhead to calculate the seek time at once. Okay, can cause second one is the can cause starvation for a request if it has higher seek time as compared to incoming request. As we know that there is the multi-user environment, so there can be multiple disk requests from the user at the runtime. So if it can be the scenario that the uh, for example, there are the multiple requests from the user to access the disk which is nearby the current request, and the what will this arm will do, that will continuously service only that request which is nearby the current request. Okay, so what will be happen, the remaining tracks which is very far away from the current track, uh, there is no chance to fulfill that request or serve request, or that request which is far away from the that track which is far away from the current track have to be wait for a long time. Okay, so it can be lead to starvation, that process has to be, that request has to be wait for a long time before serving. So it can in this, and in case of STS, SSTF, it can create starvation. Third one is the high variance of response time, as SSTF favors only some requests. As we know, in the multi-user environment, for example, there are the incoming requests which are nearby the current location or the current track. The as STF is only serving that request that is the nearby request. So with a high variance of response time, the nearby requests have the less response time, but the request which is far away from the current request which have to be wait for a long time before getting the response. Queries have the high variance. Some requests have the low response time. Some requests have the high response time. So there is a no any uniform response time. There is the variance of response time. Okay. Next one is the scan algorithm. In this algorithm, the head starts to scan all the requests in a direction and reaches to the end of the disk. After that, it reverses its direction and starts to scan again the requests in the path and serves them. Due to this feature, the algorithm is also known as the elevator algorithm. As we see the elevator, it will start from the bottom of the floor and go to the high level of the floor. So, like elevator, scan similarly work in the same manner. Okay, let us discuss it with the help of example. For example, we have these 7 requests. What will be done by this algorithm? For example, we are the currently at position number 50. We will move to the one direction. Either we can go to the upper side direction, or we can go to the lower direction. Lower direction means track number 0. Upper direction means track number 190. What will be done? I will go to the upper direction, the last track of the disk. In between, what will the request given by the user will be served. For example, I will go towards our track number 99. In between, I will serve the request number 82, then 142, 170, okay, and then 199. I don't have to serve the 190, but I have to go to the end of the disk. Okay, in between that movement, the request which will be arrived will be fulfilled. After going to the end of the disk, I will change my direction. Head will change this direction and go to the another direction. And similarly, in the another direction, he will serve the request which will come in between the this movement. Okay, in this way we have to be serve the request. For example, similarly, in the book example, for example, for example, I have uh, currently I am at chapter number 10, and there are the 200 chapters. So I will move from chapter number 10 to chapter number 200. In between what chapters I have to read, I will read the chapter. Okay, and then after going to chapter number 119, I will move my direction and I will go backward. And in the back, in the similarly in backward, I will when I will go backward, I will fulfill the request which are remaining. In this way the scalar algorithm is working. Explanation: in this above image, we can see that this arm starts from position number 50 and goes in a single direction until it reaches the end of the disc, that is request position 199. After that, it reverses and starts service in the opposite direction until it reaches the other end of the disc. This process keeps on going until the process is executed. Okay, like 150 minus 199, because 50 to 190 I have movement, and between 199 to 16 I have this number of movement, that 199 minus 16. So there will be the 332 movements. Okay, so what will be the advantages of scan? High throughput, of course, number of requests per unit of time increases. Low variance of response time increases. Average response time is average. Okay. Disadvantages: long waiting time for request for location just wasted by a discard. For example, 190. For example, I have request service the request 190. Okay. Then when will be 190 number track will be serviced next time after a long time, because this arm has to take a full movement between 192 to 0, then 0 to again in the front traction 0 to 190. So it will take a long a time of it will take a lot of time to assess the same request, because it will have to this arm has to traverse the entire disk, move coming to the same request. Okay, that is the disadvantage. Long waiting time for request for location just visited by the disk arm. The disk arm, the location which are just visited by the disk arm, we have to be wait for a long time. Now next algorithm is C-scan algorithm. C-scan means circular scan algorithm. This algorithm is almost the same as the scan disk algorithm, but one thing that makes it different is that after reaching the one end and reversing the head direction, it starts to come back. The disk arm moves toward the end of the disk and serves the request coming into the path. After reaching the end of the disk, it reverses its direction and again starts to move to the other end of the disk, but while going back, it does not serve any request. In simple words, let us discuss this example. The disk arm go from track number 50 to the another end of the disk, that is 190. So after going to 190 number track, it will move its traction and go to the jump to the another end of the disk, that is 0. It means what is the it will remove the disadvantage of the scan algorithm. What will be the disadvantage of scan? The request which is the request which is immediately service by this term have to be wait for a long time before again serving. C-scan algorithm removes or resolves this disadvantage of the scan. It will serve the request only in one direction, because for example in this example it will serving the request in the upward direction. When he it will go from track number 50 to 190, it will serve 82, it will serve 140, it will serve 150, 190 and 190. When it will go to the 199, it reverses direction and go to the another end of the disk, that is 0, without serving any request. It just jump to the another direction and it will not serve any request in between. After going to the another end, it will again going to the upward direction and again serving the request. It means that in the C-scan algorithm, the this algorithm serve the request only in the one direction. In the other direction, it just movement. It will just take movements without serving any request. Okay. If we I will take the book example. For example, I am at chapter number 50. Okay. I will from chapter number 50 I will go to the chapter number 200. In this path I will read the chapter which I have to read. For example, I will have to read chapter number 82, I have to read chapter number 100. I will read. After going to the chapter number 200, I will directly jump to the 200 to the uh, chapter number 0. Okay, I will traverse all the chapters but without reading. Okay, I will, for example, I will go to the chapter number 200. Then I will just back my direction and go to the chapter number 199, 198, 197. Okay, and go similarly I will go to the chapter number 0 without reading any chapter. When I will reach to chapter number 1, then I will again movement in the upper direction and read the chapter which are remaining. Okay, in this way this algorithm is working. Explanation: in the above this diagram, this arm starts from position number 50 and reach the end 198, 199, and serve all the requests in this path. Okay, between 50 and 198, it will request all the request. Okay, then it reverses the traction after going to the after reaching the chapter number sorry track number 199. It reverses its direction. Okay, and then go to the chapter track number 0. It will go again move to the chapter towards the largest meaning value, that is 43. Okay, then it will again serving the request in the upper direction. Okay, in this way this algorithm is working. So we can also calculate the seek time for this algorithm. uh, how I will calculate: from 50 it will go to the 199. 199. So 199 minus 50, then 199 minus 0, this movement, and then 43 minus 0. So it will take this amount of movements, that is 391. Okay. What will be the advantages of C scan? The waiting time is uniformly distributed. Of course, that is the disadvantage of scan algorithm. The waiting time is very large for the request which is the immediately uh, served. It has will wait for the long time before again served. Okay, so it will not happen in the CS algorithm. Response time is good. That is the advantage. Next one is disadvantages of C scan. The head keeps going to the end of disk. This is the main next it this advantage. The head keeps going to the end of disk. This disadvantage leads to the evolution of next algorithm, that is the loop algorithm. What with the disadvantage? For example, in this example, the last request I have to be served is 190, but I do not have to be go to the 199 because it will not. I have not to access this track, but I have to go to the last track of the disk because this is the algorithm. This is the algorithm saying. So it is the unnecessary movement between 190 to 199 because I have don't have to assess the or serve the track number 199. So it's an unnecessary movement. Okay, the head key is going to the end of the disk. Okay, even I have don't have to be assess that track. More seek movement as compared to scan. It will lead to the it will remove or waiting time is uniformly distributed in this algorithm, but seek time movements are more as compared to scan. Okay, these disadvantages then leads to the evolution of next algorithm, that is loop algorithm. So what is look algorithm? Look algorithm is similar to scan disk scheduling algorithm, except for the difference is that the disk arm, in spite of going to the end of the disk, goes only to the last request to be served in front of that, and then reverses its direction from there only. Thus, it prevents the extra delay which occurred due to the unnecessary traversal to the end of the disk. Okay, same the I will explain in the last slide. For example, last request is 190, and in the C scan algorithm or scan algorithm, I will go to the last track of this, that is 190. But I have don't have to go to the this track because I don't have to assess or serve that track. So it is the unnecessary movement. But in the look algorithm, it will see that it will look. As the name suggests, it will look what will the last request. In this example, last request is only 190. After serving track number 190, it will reverse its direction and go to the other side. Okay, it will look at what will the last request in the upper side, what will be the last request in the lower side. It will go only to the last request, not last track from the upper side or from the lower side. This is the main advantages of the look algorithm. So as I explained, the disk arm is starting from 50. and start to the serve request in one direction only, but in the spite of the going to the end of the disk, it goes to the end of request 190, okay, and come back to the last request, okay. So there will be the uh, 50 to 190, then 190 to 16, okay. So what will be the advantages? Starvation don't occur, okay. This is fairness. So starvation not any process does not have to wait for a long time. It is starvation. Starvation does not occur in the look. It is only occur in the SST. Since the head does not go to the end of the disk, the time is not wasted. Of course, time is not wasted. But between 190 to 199, the 190 head doesn't have to require serve. So it is not moved to the 199. So of course, it will not lead to the wastage of the time. It should be used in the case of less load. Okay. What is this advantages mean? It should be used in case of less load. Let us take the example to understand this advantage. That is, it should be used in case of less load. For example, there is a train going from the station Amritsar to station Delhi. For example, in the station Ambala, one of the all the passengers from the one of the box leaves the train in Ambala in station Ambala. It doesn't mean that the train will go back to the station Amritsar. It will not go to the station Delhi, because there are a lot of the another other passengers which have to go to the station Delhi. Okay, because there are the heavy load from in the other box. It doesn't mean that one box is empty, so and train will go back to the Amritsar. It will go to the station Delhi. Okay, but in other case, for example, in case of the auto, for example, the auto will go from one place to the place number one to place number two, and in between the path, all the passengers from the auto leaves the auto in between the path. So it can happen that the auto will move and go to the place number one and not go to the place number two, because it is a less load. Okay. Similarly, in case of loop algorithm, it should be used in the case of less load. If there are a very high load, then it had to go to the last track, that is the 199. It will not go. It will not go to the last request and backward extraction. Okay, it is the main advantage of loop algorithm. Okay, it should be used in case of low load or less load. Disadvantage: the arm has to conscious to find the request cluster. Of course, we have to find it. It is the main advantage of local method. It will lead to the less movement, but it has to find out what will be the last request. What will be the last one? Right? In this case, last request is 190, but it had to be calculated, or it had to be known that last request is 190, and it has to be stopped, and it has to be reverse instruction. So it is the overhead of local. It is the disadvantage. It should be used in the course of load. Of course, I am explained that it should not be used in the case of more load. Where load is less, it has to be used. That is in case of that I have explained. In case of auto, it can be used. In that case we can move from the last request. But if it is a train, we can't move that. We have to go to the last track or last station. Okay. The last algorithm is the C loop. Okay. C loop means circular loop. It is similar to C scan. It is, of course, we can see that C look is the advantageous version of look and C scan. It will remove the disadvantages of the look and disadvantages of the C scan. Okay. As look is similar to scan algorithm, in the similar way, C look is similar to C scan. This scheduling algorithm. Okay. In C look, the disk arm, in spite of going to the end, goes only the last request to be serviced in the front of the hand, and then from it there goes to the other end of request track. Thus, it also prevents the extra delay which occurred due to the unnecessary travel to the end of the disk. Like in the case of C scan, we learned that after reaching to the one end, it will go to the another end, okay, and not serve any request in between the path. Similarly, C look, it will go to the last request. Not at first it will take the advantage of look and C scan both. Okay. In C scan, the disk arm will go to the last track and then reverses its direction. But in case of C look, the disk arm will go to the last request, that is 190, and then reverses its direction in the another end. And in the another direction, it also not go to the last track. It will not go to zero. It will go to the last request in the lower direction. In case of lower direction, the last request is 16. So it will go to 16, not 0. Okay. And between 990 to 16, that will not serve any request because it circularly move to the another last request. It will not go to the another end. It will go to the another last request in another direction and then go to the again another direction. Okay, so similar to C scan, it will serve the request in only one direction, similar to C scan, but it will not go to the last track. It will go to the one night. It will not go to the one night. It will not go to the zero. It will only go to the last request, either in the upper direction, in the upper tracks, or either in the lower tracks. Okay, so it will be the advantage. It will take the advantages both look and C scan. But with the advantage of look, it will go to the last request, not the last track. Okay. But with the advantages of C scan, it will serve the request in only one direction, and in another direction, it will not entertain any request. Okay. So it will take the advantages of C scan and the example, the disk arm is starting from 50 and starts to serve requests in one direction only. But in spite of going to the end of the disk, it goes to the end of the request, that is 190, then comes back to the last request of the another end of the disk without serving them, and again start from the other end of the disk and serve request of the path. Okay, it will go only up to the last request. Okay, so what will the seek time? 190 minus 50, 190 minus 16, and 43 minus 16. That is 341. Okay. So advantages: the waiting time is decreased. Okay, the process does not have to wait for a long time. There is no request till the end. It reverses the head direction immediately. Of course, it is the main advantage. More efficient compared to C scan. Of course, less move. C scan there is a more move because it have to go to the last track. It has less movements. The time taken by this arm to find the desired spot is less, of course. Disadvantage: the arm has to be conscious about finding, of course, like local algorithm, it has to find what is the last request, either in the upper direction, either in the lower direction. It has to be calculated. It is the last direction, it has to be stopped and move its direction. It has to be calculated. It should be used in the case of more load. Of course, like local algorithm, where the load is high, there's no any meaning to reverse its direction to the last request. We have to go to the last track, but it should look and see look should be used in that case where the load is less. Okay, that's all about the law, all the algorithm related to this scheduling. It was a practice question. Please send your answers in the comment box. What is the question? Suppose a disk has 201 cylinders numbered from 0 to 200. Cylinders can be treated as a track. Similar, you can take track also. Okay. At some time, the disk arm is at cylinder number 100, and there is a queue of disk accessed required for cylinders. Request queue is that 30, 85, 90, 100, 105, 110, 135, and 145. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 requests. There are 8 disk requests. If shortest seek time (SSTF) is being used for scheduling the disk access, the request for cylinder 90 is serviced before serving dash number of requests. In this question, we does not have to find the seek time. We have to find that before serving the cylinder number 90, how many cylinders we have already been assessed. Okay, there are 1, 2, 3, or 4. How many cylinders we have assessed before serving the cylinder number 90? Okay, you have to be calculate that. Okay, and please send your answers in the comment box. That's all the session. Thank you for attending the session. I will meet you again in the next session. Okay, thank you guys. Bye bye.